Welcome everyone. Today I would like us to look at how can you determine the future terms of a binomial series. The binomial series is a formula for raising a binomial expression to any power without lengthy multiplication. The general binomial expansion of an expression of this form is usually given by, that is, a power n plus n a n minus 1x plus n into n minus 1 over factorial 2 a power n minus 2x squared plus n into n minus 1 n minus 2 factorial 3 a power n minus 3x power 3 and so on up to n plus 1 terms. N plus 1 terms. Now the value of n may be a positive integer. It can be also a negative integer, and it can also be a decimal fraction. Now when n is a positive integer, then the series is finite. The series is finite, and that means it comes to an end. But when the value of n is a negative integer or a fractional decimal, then the series is infinite. In the general expansion of the expression here, it is seen that the fourth term is n into n subtract 1 n minus 2 divided by factorial 3, and that is a n minus 3 x power 3, and the number here, the number 3, as you can see here, is very evident in this expression. All right. Now, it therefore means that the fifth term, will be given as n into n minus 1, n minus 2, n minus 3 divided by factorial 4 and multiply by a power n minus 4x power 4. And also in this case here, the number 4 is evident. It is obvious we can predict the expressions for the 6th, 7th, 8th, and so on from here. All right. But here is the case. We can use another way of obtaining the future terms of a binomial series without having to start from scratch, and this is how you can achieve that. For any term in a binomial expansion, say the rth term, the value r minus 1 is evident. All right. It may therefore be reasoned that the rth term of this expansion here, we are saying that the rth term is given by n into n minus 1, n minus 2, up to r minus 1 terms, and this one is divided by r minus 1 factorial multiplied by a power n minus r minus 1 times x power r minus 1. All right, let's look at one example. Without fully expanding this expression here, 2a plus 3b power 5, without fully expanding that expression, determine the fourth term. So determine the fourth term. So in this case here, our n is 5 here, and our a becomes 2a, our b becomes 3b, not b but x. The value of x is 3b, and then our r is 4, because we are looking for the fourth term, and r minus 1 is 4 minus 1, which is equal to 3. All right, so if r minus 1 equals to 3, then it means the value of the denominator here, we are going to have only 3 terms. All right, so that means that the first term will be n, the second term is n minus 1, the third term is n minus 2. This one is divided by r minus 1 factorial. R minus 1 here we said is 3, so we have 3, okay, factorial 3, and this one is multiplied by our a, which is 2a raised to power n minus r minus 1 we found to be 3, and multiplied by x, but our x here is 3b, so that is 3b raised to power r minus 1, which is was found to be 3. Right, so we are looking for the rth term, and from here we can go ahead and simplify. We find out that the rth term becomes let's slot in our values. The n value we said is 5, into 5 subtract 1 is 4, 5 subtract 2 is 3, and divide that by factorial 3. All right, and this one is multiplied by 2a raised to n minus 3, n is 5, and that one multiplied by 3b raised to 3, and this one simplifies to the whole of this one becomes 60, divided by the whole of this, which is 6, multiplied by, so here we have 2a raised to 2, because 5 minus 3 is 2, and then multiplied by 3b raised to 3, and this one becomes equals to, if you simplify that, we shall have 10 times let's pick the whole numbers. We have 2 raised to 2 times 3 raised to 3, and times a power 2 b power 3, which simplifies to 1080 a squared b power 3. Okay, just to confirm all these, let's look at one more example. Without fully expanding this expression, determine the fifth term. The fifth term. Again, here our value of a is 3 here. X remains equals x. N is our power there, which is 7. Our r is 5, because we are looking for the fifth term. and r minus 1 equals to 5 minus 1, which is 4. Now again, from our formula, the rth term is given by the rth term now becomes the value, the number of terms is going to be 4 here, because r minus 1 is 4, so we shall have the first term, the second term, the third term, and the fourth term, divided by r minus 1 factorial, or factorial 4, right? And this is multiplied by a. The value of a here is 3 raised to power n. Our n is 7. Subtract r minus 1, which was 4, multiplied by x to the power r minus 1, which is 4. This one simplifies to 7 into 7 subtract 1 is 6, 7 subtract 2 is 5, 7 subtract 3 is 4, divide by factorial 4, that is 4, 3, 2, and 1, multiply by our 3 raised to 7 subtract 4 is 3, multiply by x raised to 4. All right. This one simplifies to, you shall have the numerator here, the whole of this will give you a value of 840, divided by this one here gives you 24, and this one is multiplied by 3 raised to 3 x raised to 4, and simplifying further, this one becomes 35 by 9, because 3 power 3 is 9, and then that is x raised to 4, which gives us 945 x power 4. So this is how you go about working out or determining the value of future terms of a binomial series using this formula here. I hope you enjoyed this video, and if that is so, show some love by giving it a thumbs up. Give your feedback under the comments section. I'll meet you next time for more videos. Until then, nice time, take care, and God bless you. Bye bye.